When we excitedly talk about AI as an effective means to boost productivity, not everyone realizes that we are nurturing a massive artificial baby. At this stage, it's not just one baby, but many. This artificial baby not only needs food and drink, but also requires continuous learning and growth. This is a metaphor, of course. The food and drink refer to the enormous energy demands, and the baby's need for learning data is also considerable. Let's have a brief look at the background of AI data training. As early as 2006, Professor Fei Li, then at the University of Illinois, recognized the effectiveness of internet data in enhancing AI training. As Li said, a lot of people are paying attention to models, let's pay attention to data. In 2009, after moving to Stanford, Li and her team created DataImageNet, a large visual database for visual recognition research. This database has since been widely used to train and validate various computer vision models. In a 2012 ImageNet competition, a deep convolutional neural network (CNN) model called AlexNet stood out, demonstrating the powerful capabilities of such networks in image recognition tasks. Since then, buzzwords like deep learning and neural networks have frequently appeared in academia and industry. The three members of the AlexNet team are now leading figures in the AI field. It can be said that applying internet data to AI training research propelled the start of the AI wave. It's worth mentioning that, back then, training data typically needed to be manually labeled to improve data accuracy and effectiveness. Amazon even established a crowdsourcing platform, Amazon Mechanical Turk, to allow internet users to complete tasks like data labeling, image recognition, text transcription, and surveys for payment. With the rise of large language models, LLMs, AI model training has changed. LLMs use self-supervised training, which trains models using unlabeled data. This means that training data no longer requires manual labeling, and the more data, the better the training results. Naturally, the internet have become ideal training mine. As the amount of AI training increases exponentially, the performance of AI continues to improve to meet expectations. However, as this giant baby grows, its appetite also increases. Nowadays, AI developers not only face the need to add more chips and enhance server computing power, but also need to provide a continuous supply of high-quality training data. When discussing this, you can see that the rapid development of artificial intelligence in the foreseeable future hinges on three core elements. First, electricity, with expectations on whether nuclear energy can provide a backup. Second, computing power, as NVIDIA's chips are getting larger and more expensive, but there are still solutions available. And lastly, the soon-to-be depleted training data. At this point, you might wonder, isn't data on the internet being continuously generated by our lovely internet users? How can it be running out? The reality is that this giant baby has a very large appetite. According to a research organization, Epic AI, by 2028, all high-quality text data on the internet will be exhausted. This phenomenon in the AI field is known as the data wall. Additionally, because much of AI training is based on public data, issues around whether this infringes on public privacy rights are increasingly coming to the forefront. Different regions have varying levels of awareness and protection of public data. European countries, in particular, have stricter policies and regulations, resulting in less usable data. As people pay more attention to these issues, future restrictions on obtaining training data may increase. Therefore, the current problem facing AI development is not a shortage of electricity or computing power, but a foreseeable lack of learning data in the future. How can we solve this problem? There are several methods, some of which are still in the experimental stage. Here are a few examples. The first solution is, if text data is insufficient, we can use video data, assuming we have enough computing power. OpenAI's GPT-4o and Google's Gemini have already incorporated videos, images, and audio into their self-supervised training. Using video as training data is relatively difficult due to the high data point density in video files. Therefore, current model training usually simplifies the process using a series of video frames. Another method is to use synthetic data, which is AI-generated data. A typical example is Google's DeepMind team developing Alphago, a specialized Go-playing AI. Initially, Alphago was trained using a large amount of real-world Go player data to create the first successful Go model. The upgraded version, Alphago 0, learned winning strategies by playing against itself. The biggest advantage of using synthetic data for AI training is that there are no privacy infringement issues, and the data can be used endlessly. However, the downside is that machine-generated data may not accurately simulate the real world. The data may lack detail or differ in distribution from real situations, leading to decreased training effectiveness. Lastly, a fundamental solution is to optimize or upgrade existing models, allowing better training results with less data. For instance, self-supervised training can improve training results by incorporating human feedback mechanisms known as reinforcement learning from human feedback. This involves asking questions, having the machine answer, and providing human feedback on the machine's responses. This feedback loop allows the AI to continuously improve, producing answers or results that meet human expectations. Of course, the best solution would be new models that can replace the current transformer models, which are very data and computing power intensive. Optimists might say there are always more solutions than problems. However, nurturing this AI giant to produce real productivity value will still take time and come at a significant cost. As the saying goes, let's take it one step at a time. Okay, that's it for today. Thanks for your watching. See you next time.